In this more advanced example, we're going to use network analysis in order to gain an understanding of the topics in a large text. The basic idea is that by using networks, we can better understand the relationships between nodes. The crucial step is to represent text in a network, and thus we would like the nodes in the network to map to concepts in our text. Thus, we will be combining text analytics techniques in addition to network analytics to get to that understanding. The text we're going to process is basically the text of the US Constitution. Now, this is a large piece of text, so understandably, we would like to rely on these methods in order to understand text without reading it. These techniques are becoming more important, especially when analysts are working with large amount of text. Okay, so let's go through the steps. The first step is to basically break this text into sentences. And then for each sentence, we would like to use named entity extraction and identify the named entities. We're doing this step because we think that named entities better reflect conceptual topics in the text than any other word. Next, we're going to create a network in which the nodes are the named entities and the links are simply whether the two named entities occurred in the same sentences. However, we would like to weight the network. We would like to keep an account of the number of co-occurrences so that we can use this weight information later down the road. Once we have the network, we can start looking at the most frequent relations in the text. We can look at the influential nodes, basically important topics discussed in the text, and we can visualize the network to gain an understanding of the relationships in between these topics. Alright, so let's get started. The first step is to basically sentence segment the text. So I'm going to use text blob for this task, and I'm going to create a text blob around my text. Once I do this, I can call the attribute sentences, and let's take a look at the first perhaps 3 sentences here. Okay, now the next step is to go over each sentence and extract the named entities. I'm going to use Spatie for that. And I'm going to write a function. Since I'm going to repeat this process for each sentence, I'm going to write function. Let's call this function getNamedEntity. And this function will take a text and then give us back the named entities. I'm going to ignore the type of the named entities because I don't want to restrict the type. I think in general it may be helpful to make this function more powerful so that we can filter named entities of interest. For now, I'm going just to get the text for each named entities. And we get the named entities by calling the ENTS attribute of the document that the Spatie language model create. Okay, next step is to basically calculate the named entities for each sentence. Now don't forget that for each one of these sentences is a sentence object, so we need to get the text of that sentence, and we get the text by calling the attribute raw. So I need to get named entities for each sentence dot raw for sentence in sentences. Okay, that's named entities. Okay, let's take a look at what we've got here. So for instance, in the first sentence, the named entities are the United States, welfare, the blessing of liberty, United States of America. In the second sentence, it's Article 1, and so on and so forth. So that's very good. Next, we want to count count how many times two entities occur together. We want to create the combination of these occurrences. So for the first sentence, we have a relationship between the United States and welfare, the United States and the blessing of liberty, the United States and United States of America, welfare and the blessing of liberty, and welfare and United States of America. Okay, so how do we do that? There are multiple ways of doing it. I'm going to use just plain vanilla Python for doing it. I'm going to go over each sentence, well, it's not a sentence, it's list of entity, let's call it list entities, in named entities. This list comprehension doesn't do anything for now, it's basically recreate the list. Next, I want to go over each one of these lists twice because I want to combine each word with each other word. So what I'm going to do now, I'm going to basically combine word 1 with word 2. For each list of entities in named entities, and word 1 for each word 1 in LE for each word 2 in LE. So basically for each sentence I need to go twice, 2 loops, word 1 and word 2. I'm going to add a condition here just to make sure I don't associate the word with itself. So I'm going to do word 1 is not equal to word 2. So for instance, if you take a look here, you can see that we combine the United States with welfare, blessing of liberties, United States of America. The only issue with this approach is that it's going to repeat the combination welfare to the United States, although we have accounted for it now. This shouldn't be a problem for our application because we're going to use an indirected network, and when we add edges to the network, they're going to be discarded anyhow. Node 1 and node 2, a relationship between node 1 and node 2 is equivalent to a relationship between node 2 and node 1. Let's call this one edges. I'm going to call it edges, maybe edges 1 for now, because the next step is to calculate the frequency of these edges occurring together. Like for instance, you can see that United States of America and welfare happens again, and there are many repeated combinations that we want to account for. So there are multiple ways of doing this counting. I'm going to use the counter class from collections. And I'm going to create a counter object on edges 1. So it's going to create kind of like a dictionary associating the keys, which are the items in the list, with their count. So most of them will have a count of 1, and that's to be expected, but some of them will have a higher count. And those are the important relationships that we want to focus on in our analysis. I'm going to call this one edges for now. And the next step is to basically create our network. So I'm going to create a brand new network. And then I'm going to go over each one of these edges. Now don't forget that this is kind of like a dictionary. So if I go iterate over it, it's going to iterate over the key. So I'm just going to put here a print for you to see, right? That's the key. Now the value itself is basically edges. It can be accessed by accessing that dictionary at that key. Okay, so that's the frequency here. Now, if you take a look at this, the key itself, the key itself is a tuple. So node 1 is the key at 0, and node 2 is the key at 1. So I'm going just to take node 1 and node 2, and frequency is basically the edges at edge. Okay, so I hope this is now understood. And we need the 3 components in order to create our edge in the network. I'm going to call the function add edge. And I'm going to add node 1, node 2, and the frequency will be the frequency. That basically keeps the frequency information in our network. Now, what I'm going to do now, I'm just going to ensure that I got things right? These are the edges. And again, I can put data is equal to true so that I can see that, data information here. And it looks like I kind of loaded things correctly to the network. The next step I'm going to do now, with data loaded, I'm going to start, looking to see what kind of patterns we have here. Now, first, I'm going to look at the most frequent relations in my data. So I'm going to look at the network, and I'm going to actually sort the edges by their frequency. So what I'm going to do here, I'm going to recreate this. I'm going to say network edges is this one. Now network edges, if you take a look at each one of these network edges, let's take a look at the first one. Oops. Let's take a look at one of them. That's the first one. You can see that it has the node itself, the node 1, node 2, and the data itself is a dictionary in the tuple. Okay. So what I'm going to do now, I'm going to create a list that contains the only issue here is that I want to take out this one from being in a dictionary. My goal is to create a pandas data frame from this data here. Okay, and the issue here is that I have the frequency because it's a dictionary. In general, it's possible to load multiple attributes on an edge. So what I'm going to do here with my data, I'm going to create a pandas data frame. There are a couple of transformations needed. What I'm going to do, I'm going just to call data.columns will be, I'm going to call it n1 and n2, and this one is going to call it f for now. Next, I'm going just to unpack this from being a dictionary to being one value. So I'm going to create a new column, data frequency, and I'm going to look at data f for now and apply a function. This function should be straightforward because each one of these x's is a dictionary, so x of frequency will be the value associated with x. Let's take a look at data again here by looking at the head, and you can see that we unpacked frequency here. The last step I want to do is to drop f, so I'm going to drop f, and because f is on the column axis, I'm going to say axis is equal to 1. That basically drops the column from the data frame. Okay, so that's my data frame. Next, I'm going to sort values by frequency, and I'm going to make ascending here false. And let's take a look at the first 25 ones. Those are the most frequent relations in the data. And as you can see here, many of these relationships now make sense, but there are some interesting ones. Next, we're going to look at nodes, and we're going to sort nodes to examine the most salient, interesting, important, influential topics. So I'm going to use centrality measurement, and I'm going to use degree centrality and betweenness centrality or closeness centrality to get two different views of importance here. Once again, degree centrality examines the node irrespective of all other nodes in the network. It only looked at immediate neighbors. So those are basically the concepts that have been repeated many times in the Constitution, irrespective of where were they repeated. These locations were also repeating any other topics or important concepts in the Constitution. I'm going to do the network centrality of the network, and I'm going to sort. So I'm going to create a pandas series, and I'm going to sort values. Ascending is false, and let's take a look at, for instance, head 25 or 20, and you can see those are the topics that were repeated many times in the Constitution text. Now I'm going to do the same, except that instead of degree centrality, I'm going to take closeness centrality. And this will only this will rank these topics by the degree to which they're close to other topics. And this takes into consideration the whole structure of the network. So I should see a different list that contains more important topics than the ones given by the degree centrality. And as you can see here, if you take a look at this list here, you can see that many of the people's names there are not coined. So each one of these centrality measurement is giving me a slightly different kind of understanding of the most important topics in the text. Next, I'm going to draw the network just to gain kind of a visual understanding of what's inside it. The relationships of these topics can lay out in kind of a, a map that we can examine visually. Unfortunately, this is not very easy here because the network is very large. So unless we draw it very carefully or we have a very kind of large screen state, it's going to be a hairball, especially that the labels themselves are very large. So what I'm going to do, I'm going to recreate the network and only focus on very frequent edges. So I'm going to basically take the same code that I used above, which probably means maybe I should isolate it in a function. Anyhow, I'm going to take the same code and I am going to create a new network, but I'm going to filter edges based on frequency. I'm going to keep the original network, so I'm going to create a new network object here, and I'm going to paste my code here. The only difference is that I need to make sure I'm updating net2. The other difference is that I need to filter these edges based on frequency. So I'm going to add an if statement here to look at frequency, and I'm going to apply an arbitrary cut point here, maybe greater than 6. Next, I'm going to draw network 2. So let's draw NX, draw network 2. And of course, I want the labels here to be drawn. So I'm going to add with labels to be true here. All right, so this is kind of a conceptual representation of topics in the US Constitution. And obviously there is room for improvement here. Some of these concepts, such as the United States and United States, should be unified. For instance, the House of Representatives and House of Representatives as well. But nonetheless, this is kind of give us kind of a broad kind of level, high level understanding of what this text is about. The last step is basically to understand the substructure of this network. I'm going to use community detection again. And basically I want to group nodes by groups, communities that are kind of correlated together. Let's take a look at using the community module, and I think I imported the community modules above. So I'm going to call the community greedy modularity communities, and I'm going to pass network here. Now this algorithm takes an optional parameter, which is the weight. This is important because not all edges are created equal. I'm going to create my communities here. Let's take a look at these communities. We've got 15 of them. And obviously we need to examine these communities. Those are the result of a clustering algorithm to kind of make sense of what they are about. Conceptually speaking, they will be about nodes, which are representing named entities or topics related together in the text. So let's take a look. The first one, interestingly, has numbers as well as names of people. So interestingly, you can see that the founding fathers and other people name are grouped in one community here. That's interesting, and this is actually a pleasant surprise here. There are some, if you take a look at the second entity, it's kind of mostly about topics related to events. This one seems to be more about voting and elections. And obviously, some of them may not make sense at the end. If we scroll down, we can see that this community is more about institutions of the US. Some important dates. And interestingly, one of the communities here is basically combining the state names. So that's also interesting. Many of these communities make sense. We need to take a look, and many often fine-tune the algorithm to get a better understanding. Nonetheless, with this kind of basic analysis allowed us to kind of compress and condense a large amount of text and get a high-level understanding of what the text is about.